Okay. Hello everyone. Welcome to another week of We Are Knowledgeable. For those of you who just joined for the first time, We Are Knowledgeable is a sharing started from our React team. We cover topics we find interesting as a React developer, but we don't only talk about React. We talk about other stuff like today. So also, whether you are working in Shopee or not, you are welcome to give a sharing that you find interesting as a web developer or as a developer in general. You can always find us. You can wait, I think my slide. Okay, so here is a link to our issue today. You can find the links of today's talk, as well as resources and follow up with videos later on. We're still stuck at home. Some of us are in office already, but most of us are still stuck at home with COVID situation. Next week, some of us will be back in office, but because we still have the meeting room capacity requirement, we cannot host everybody. So next week, we will still be sharing these remote. And I also want you guys to know that even after the whole COVID situation is over, we'll still keep live streaming our event that are doing fit for public. So you can stay with us to see what we have to share from our team. So shouting outs to Shopee for hosting us throughout. Also shouting outs to Engineer SG for providing guidance and support for our live streaming and recording. If you just joined the live streaming, now is the time for you to say hello to everybody, say nice things to each other, introduce yourself. If you are here regularly, welcome our new joiners. Feel free to chat around a little bit. Right, so like I mentioned earlier, we welcome you to give your sharing. Right now, we're working on schedules for August. There will be a soft topic event that we've been preparing but keep postponing. Also, thanks to COVID. And there is also another interesting topic proposed by one of our developers that will likely come later in the month. But other than that, August is still empty. So if you have anything interesting you want to share, do let us know. We're getting back in office, so it's easier to get hold of us. And if you do not work at Shopee, you can use this link to submit your proposal. Right, okay. Singapore CSS is happening next Wednesday, number 52, the first day of July. Also, Junior Dev SG is having an online hangout on July 16. It's a Thursday. Thank you for going around schedule collision with RK. Please go hang out there if you have some time. There is an interesting talk about AWS happening there. If you want to learn more about the technical meetups, events happening in this town, right now most likely will be happening remotely. You can check out engineersg/events and you can find all the information there, and as well as recordings. Yeah. So for today's topic, Hui Jing is our friend. Hui Jing has been showing up very regularly, so she is sharing with us about CSS colors. And before we do that, actually we have Li Hao, who has something to share with us about Sass color functions also. So, so Li Hao, are you here? Let me stop sharing. Okay, I actually cannot hear you. Is there something wrong with the audio?
Yes.
Okay,
I think I just didn't speak anything.
Oh, okay. Hello, Li Hao. How are you doing?
Yeah, I'm doing fine.
Great,
so
great.
How's everyone?
I think we cannot hear everybody's answer. I think looking at the emojis in the channel, looks like everybody is clapping and washing their hands properly. So yeah, so you're you have some interesting discovery about SAS color functions, right? Why don't you tell us a bit about like what they are and how you discover them? Like what are the sources? Yeah.
Okay, so
I think you should start sharing your screen because I'm not seeing anything. But yeah.
Okay, let me share my screen. Can everyone see my screen right now? Do I need to stop my camera?
I think you're looking good. Although I think our Zoom looks like a bit stuck. Maybe Ken can help us debug a little bit. But your screen and your sharing looks good. So yeah, please go ahead.
Okay, so yeah, so about SAS color functions, right? So I think not sure whether everyone knows about SAS. So SAS is like a awesome CSS, right? That allows us to write slightly more elegant CSS that with like a more synthetic sugar on top of it, right? So um, so how did I found so SAS itself provides a lot of helper functions. If you guys don't know, if you are just using it just like CSS, you are actually losing out a lot of very interesting features that SAS is providing. And so today, why I'm going to share about SAS color functions is that because Hui Jing later on will be talking about colors, right? So I find it so this is a topic that I was thinking of sharing for quite a while, but I find it like it's very uh, I don't have a lot of things to share about, but it's just very interesting that I find it I want to share about, right? So I think this. Sorry.
Yeah, before you start, please zoom in your font a little bit.
Okay, cool.
Yeah.
So this is something I've been thinking of sharing. So that's why I find it maybe this is an opportunity to share like what is like SAS color functions, right? So before I share about what is it, right? Like so you asked about how did I discover about all these color functions in SAS? Is that actually back in my previous company when I was like working on design libraries, right? You know, designers always like to have like color palettes, something like this, like the color systems, where they have a list of colors, right? And within one colors, right? Maybe like the red color, they they although we don't know, like, but actually how the color itself has some relationship with each other, right? Like maybe the darker red and the lighter red, they are like, you know, in terms of certain properties of the color, they have certain relationship within each other. And yeah, so that was what the designer gave me, right? They told me like, okay, the base color is this color, and then if you hover on top of so the base color of this button is a certain color, and if you are hover on top of it, it should turn lighter in like 10%. And if it's disabled, the saturation, like the color itself saturation should be dropped to say 25% and things like that. And the base color could be any colors because, you know, like sometimes your design, you have like a primary color, you have a secondary color, and you may have like different color depends on your design, right? So if we are going to calculate that every time, then it will be like, it will be it's not you could do it with like SAS that it actually has like features to have you calculate those colors based on certain functions, right? So over here.
So we can't do it. It's just a lot of magic numbers.
Yeah. So over here, I have like a grid of boxes. So I'll be, yeah. So the code itself has nothing. It's like a grid of boxes, and later on I'll be adding classes to each box, right?
Okay.
So yeah. Okay. So right now I only have like the one class called red color, and then the color is red, right? So sometimes, so the first thing we talk about colors in SAS, right? besides providing hex, you can do it. I think just like CSS, you can also do it with like, say, background is with a HSL with 0, 50%, 50%. Right? You can do it with HSL and RGB as well. So, but one thing I find it useful is with the RGBA version of the SAS. So let me go for a red color first, right? What will
You misspelled
background?
background.
Yeah. So one thing I red, green, blue, yellow. Okay, so opacity is 100%, I think. So one thing I find it useful is that okay, say 50%, right? I can use, instead of providing RGB value, I can replace it with like a variable that represents the RGB. Yeah. And I just changed so I think in Shopee we have a lot of like black color of 10%, 20%, 30%. You can do it this way. You don't have to like specify all the like the colors itself. That's one thing I find it useful. And then the next thing would be actually extracting color channels from a color. So for example, I want to specify in terms of HSL. So HSL stands for hue, saturation, and lightness, right? So RGB is red, green, blue, and alpha. So alpha is like a transparency, and red, green, blue is like the color channel, like red color, green color, blue color. But for HSL, right, it's a different color space. I think if you inspect element, if you look at, there's a color picker that is like a circular. Yeah, that would describe the HSL much
I believe
easier.
we'll go in detail about this later on. So
yeah, so
yeah, let's we can leave this part open for later on. Please continue your
yeah, so quick so hue, I think I just like drop like what's hue stands for. Hue is just the color, so it could be like any color. So it's like over here, any color is the hue. So you see when I adjust, the hue just changes, right? And the saturation is the 0 stands for no color at all, and 100% stands for full of colors. So if you move horizontally, like from no color to with color, then you see the hue moves from 0 all the way to 100. And the lightness stands for like white. 100% would be a full-blown white color, and 0% would be no light, so it's like a black color, right? So yeah, so that's the HSL. So for example, I have a color right now. This is the I'm not really sure about the. Okay, let me see what's the HSL for this one. So
we're using Chrome. Okay.
Yeah, in Chrome, right? When you whoops. Okay. In the meantime, okay, it's up. So you can switch. Okay, let me see. I think I can do a zoom. Okay, you can switch between different channels. So you see the hue is 5. So hue goes from 0 to 365, if I'm not mistaken, and then back to 0. So it's a degree. So okay, whatever. Okay, so for example, if I want to just get a hue and then I change the saturation, I want this color's hue. I can do it like, for example, I can say hue of this color, and then I change saturation and lightness.
So that's a SAS function, right?
Yes, this is SAS function. So if you look at the CSS, it's compiled down to the actual.
Oh, okay. So it does the computation for you.
Yeah, correct. So all this is done in done in SAS, and it's compiled to just, I'm not sure whether it's hex or maybe RGB. I'm not really sure about that one. Yeah, but it's compiled, so you don't see all these functions anymore, right? So similarly, you can get like the saturation of the color, and as well as like, okay, although it doesn't make sense to put saturation and hue, but like you can do saturation as well as lightness, as well as like transparency or alpha. I think they have like
Right.
multiple names of the similar things. So I guess it's more like a user friendliness of it. Like you can say it's alpha, you can say transparency, and you can say different names of the same thing. Yeah, so that is one. So that is like how you can specify colors.
Can you build function? Sorry, can you build functions on top of those functions?
Yes, you can do mix-ins, right? Yeah, I think I will show on that. I will have an example on that one later on. Yep.
Okay.
So so I think on this one, right, it may seems a bit verbose in the sense that you have to get the color of this alpha, like a channel of this, and then you specify the this is you specify absolute of saturation and lightness and things like that. One thing you can do is also so right now I'm going to have like 2 more classes because so that you can see the color side by side. So there's a red disabled, which is the one I'm going to say that the saturation will be slightly like saturation minus 25%. Okay, designers say one, I don't know why, but red like maybe like a when you hover on it, you have a like a hover version where maybe it turns slightly brighter, like brightness maybe plus 5%. Okay, right. So I have 2 class. Now I'm going to add like define them. So for disable, what I can do here is that background equals so instead of just do this, right, what I can do is I have a function called adjust color. So
This
adjust
is also
color,
a Sass function.
yeah, correct. It's another Sass functions. So you can so the first one is a color. So I pass in like this color, right? Or short form is I can just do it this way. And then over here is like it's a what do they call it? Like it's optional parameters, like name parameters. I think some languages have that, like name parameters, so you don't have to specify all of them. So you can just choose. All of them are optional, and you can choose like what you want. So for example, in this case, I only want to adjust saturation, right? And I want to adjust like minus 25% of it. And here I have my color, right? So to prove that it works, I think we can look at here. So HSL is like 566.57, and over here oh wait, I need to change back I need my original color. Okay, sorry. Okay. I think this one will be HSL will be yeah, 91%. Disabled will be 66%. Is it correct? I'm not doing my math correct. Yeah.
Minus 25% or multiplied by 75%. I don't know.
Minus 25. Minus 25%.
It's minus 25. Yes. Yeah, it is.
So. Yeah.
Yeah, it's minus.
So,
okay.
Yeah, correct. So you can do like maths over here to change the color you want. And yeah, so you can do it for saturation. You can do it for why are you doing this to me? Okay. Yeah, you can do it for again like the lightness hover, and then I do the lightness. So besides adjust color, right? In some cases, like for example, I showed just now, we want absolute value of the saturation, right? We don't want to adjust like plus minus. We want an absolute value of that thing. So there's another function called let me add one more class. I don't know. Okay, I'm bad at naming, but there's another function called change color. Change color. Right. In this way, you set absolute value of channels. So you can set absolute red color, right? So for example, right now my color, right? If you look at the red is F5, right? I want it to be just full red. on the red channel. Yep. Let me add one more class. Oh, then yeah, so this way, this one, if you look at the color itself, this is FF, like full blown red color. So you can set absolute value of each channel. So the channel they have is red, green, blue, alpha, and hue, saturation, and lightness. Right. And I think the last one I have is mixing colors, right? So sometimes you have designs where, you know, the background is a certain color and the text is certain color, and and a certain transparency also. So when you overlap the text and the background, you see like a mix of both, right? Like a mix of both colors. So if you do with a transparency, like for example, if I put a red color with 50% transparent opacity, and if I scroll around, if the background has different colors, then you will see that it changes. You can see through, but in and sometimes, you know, designers, maybe they're picky. They just want the in between colors, and it doesn't want like the see-through feeling. It just want like, you know, this is like 75% transparent, but I don't want, you know, if the background is red, I don't want to have the text to be a reddish or something like that. So what you can do is you can mix color. You can add two colors together and you change the ratio of mixing between the two. Yeah. So, and also that when you mix color, you compile it down to actual colors, right? I'm not really sure whether, you know, compositing colors with transparency will make, you know, I don't know how. I wouldn't say like, maybe it's just a small performance gain where you know you're not having transparency. You have that fixed color, so that you don't mix it during rendering where your browser is compositing the layers. But anyway, let me show you how you can mix colors. Over here, what I'm going to do is that I will mix blue with red together. So what I'm going to do here is I'm going to show you like a shade of blue and a red mixing. So I'm going to have maybe okay, sorry. I should have typed this earlier on, but red, blue, what? IDEX. Okay. So we have red, blue, 0. Okay, maybe add a 10. Red, blue, 0, 0, 10, 0, 1, 0, 2, 0, 30, 0, 40, 0. So it's like a, I will go for 10% of blue and then all the way to the 90% of blue. Okay, and here is what you can do with SAS. You can write a for loop to generate all the classes, and I think I mix it a bit. I think blue, if start with 10, 0, then it should be like this, right?
Okay.
Yeah, so
That's
yeah,
nice.
you can mix, yeah.
That's nice, yeah.
Yep. So you can mix the color, and the percentage over here tells like how much you want the first color to be, and then the second color will be the 100% minus that percentage. Yeah. So you can do it with like a for loop. You can do it with like a mixing of you know, like a right here, like mix color, and then you can like say pass in different colors, color 1, color 2, and then, you know, you can define that as well. So yeah, but yeah, basically you can do mixing, you can do changing colors, adjusting colors, and you can like you can get certain channels from a color and then manipulate with that. Yeah, so these are like I wouldn't say you wouldn't need it like every day, but once in a while when you need to, define one base color and generate a shades of multiple colors based on that with a certain set of rules. Like color have certain rules for the designers, right? When you need that, maybe you can think of like SAS color functions. They might help you.
Great. Okay, cool. Well, thanks for sharing with us. I think we are using more time than we planned. So let's move on with our actual sharing today, because it's really very highly relevant. So hint to our sharing. Wouldn't it be nice we have that in CSS? So okay, let me. Okay, so pass. So later on we'll have Hui Jing to share with us about colors. We actually have a fan base of the book called The Secret Lives of Colors. It has been passing around in our team, I believe, for a while. So yeah, this is a very interesting sharing. So I think Hui Jing, are you here? Let me pass this to you.
Hello, can you hear?
Yes, can hear. Can you?
Oh, it's now 6:30. I think I might encroach into all the people who want to go and see girlfriend, boyfriend. So I like, if you want to drop off, can drop off lah. Like this is the standard CSS spiel where it's like, you want to come, you come. You don't want to come, never mind. We don't really. Oh shit! Never close my rubbish windows. Okay. Okay, I will skip the boliao sheet. I had some boliao sheet to fill time, but like, okay, now I just start. So these are let's to be. I go already. How I start already? Start already. Oh, the host has asked me to start my video. Click. Do I go? Someone say action.
I think let me see what shows up.
Please go.
Yes, can go now.
Okay. Yes, sir. Okay. Yeah. So for context, actually, this was my backup CSS talk. Then so like when nobody want to speak, then I will pull this out of my back pocket. So it turned out to have more colors than CSS. So this talk has like no React, no JavaScript, limited CSS. Oh well, moving on. Yeah, okay, this is the part where I talk about the CSS part. Yeah, so I wrote a thing last year, because a wise friend once asked me why the CSS color snow looks a bit red. I still don't know the answer to that, but I found a lot of other things. But you should really hear from a professional. So there's this Increment magazine, which is a web, I would call it a web development and design magazine published by our friends at Stripe. They have a printed version. The online version is free. You can actually buy the printed version. It's very good. Last issue was front end, so it's really relevant for all of you who don't care about CSS. Don't worry, I think about 2 CSS things. There's like more JavaScript heavy stuff there, so like just go and read it. It's a very very well designed website also. So anyway, inside there's a lot of history behind why CSS is the way it is, because the gentleman who wrote this article, his name is Chris Lilly. He was, I can't remember his current title now, but he's the one who proposed fonts, SVG. He does a lot of the color stuff. So he's like he has basically been writing CSS before all of you were born. Okay, so let's just leave it at that. So I heard that you all like that book, The Secret Life of Color. So in reference to this particular quote by Sir Isaac Newton was quite in front. So if you're the type who never read, only skim the front part, you might have seen this. I think it's it's kind of an ode to colors. So like Sir Isaac Newton, right? If you all never heard of him, I just don't know how to explain lah. I mean, this guy, he apple drop on his head, okay. But like where he was, I would say he is like late Renaissance. But if you think about it, right, during the Renaissance period, I feel that there are a lot more polymaths around. Polymaths meaning people who are very well-rounded. They're not like very focused on one thing. So if you're a scientist, also you're also an artist, you're an architect, you're a mathematician, you're a musician, you're a poet, like all at the same time. Like it's like, can do everything. So even though like he's people remember him for the theory of gravitation, his gravitational theories, right, he also had a lot of color theory related, I would say, it's a treatise. People in the Renaissance period like to write treatises. So in the early days of color theory, most of the color theories stem from artists, right? That, you know, like the Renaissance painters, very, very, very talented. So it was very, I would say, paint related. And the primary colors used to be thought of as red, blue, and yellow. In theory, the proposal in the early days was like, okay, using these base colors, whereby these are the colors that you cannot get from mixing other colors, so they're primary, right? In theory, if you mix all of them, you should be able to get all other colors, but actually it's not true. So formalized color theory started a bit after the Renaissance period. So Sir Isaac Newton wrote Optics, which is, I think it's originally in English, legit. So this is actually not a translated code. It's like he wrote it in English. There's link to the full text, because like I think so many years then not copyright now, then someone put the full text online. So if you're interested, there's link to the full text. So it's in English, so you can read. But inside this treatise, right, he proposed a couple of things. So his analysis of color stem from light, which is different from paint. And he proved that light was composed of different spectral hues because he did his experiments with prisms. So I don't know, like in primary school, we all got play. Like when in primary school, right, I think they need to entertain the children. Then they're like, you go outside and then you take this block of glass and you see rainbow. And, oh, wow, so nice. Yeah. But like back in the day, this was not something you taught to primary school kids. He needed to do a lot of like experimentation before people discovered that, like, you know, white light is actually made up of a spectrum, right? So this is, if you read the full text, right, this particular code is proposition 5, theory number 4. Yeah, okay. So the question now is, what is color? Objects have no color until light hits them. Think about this sentence, okay? Color comes from light. So what we perceive as color lies along this very narrow spectrum known as visible light. And things around us, you know, you look around you, what do you have? Some of you got tables, some of you got chairs, some of you got wife. They all reflect light in different combinations of wavelengths. So when they reach, so our eyes have these things called cone cells. And when these different combinations, when these light of different wavelengths reach these cone cells inside your eyes, right, your brain will interpret them as different colors. So it's highly possible that like what I see as red might be different from what you see as red. Even though objectively we are seeing the same wavelength, the way it gets interpreted in your brain actually is slightly different person to person. So that I thought that was quite interesting. So light is actually something that's perceived visually through the stimulation of these photoreceptor cells by the electromagnetic radiation that the things around you have reflected or emitted into your eyes, right? So for human eyes, humans, I think most vertebrates never study bio properly in school. So I think so for our eyes, these are cone cells that I mentioned. Light actually is very special. Light is one of those things that's still a mystery because it can both be a particle and a wave. It's like for all the men out there, your wife can both be right and wrong at the same time. Amazing. Please think about that. Anyway, but light is very special because it carries energy, but it has no mass. And everything in the universe, right, is made up of atoms, right? As far as we know for now, it's made up of atoms. And atoms are also made up of constituent things. Atoms are made up of protons, neutrons, and electrons. So protons and neutrons are, those of you who never take physics, I'm going to remind you what happened in secondary school physics. Protons and neutrons actually have a sizable mass compared to electrons. So they form the nucleus of this atom. The orbits just like, you know, rotate around this nucleus, right? So every atom has its own set of electron orbits. So it's actually quite parallel, you know, like on a micro scale and on a macro scale. You think of like planets revolving around the sun, right? Electrons revolve around the nucleus. Amazing. Nature. Anyway, these electron orbits, they are fixed. So how should we put this? The orbits themselves, right? They are determined by the energy level. So every orbit has a fixed energy. But sometimes electrons can jump from one energy level to another. Okay. So here, if you are very into physics, like, hey, wait, something wrong. Because if you remember, there is this particular physics theory formulated by the French natural philosopher. I cannot pronounce French names. I think it's Emily du Châtelet. So she was a natural philosopher and mathematician. And the conservation of energy, she derived them from the principles of mechanics, which is, long story short, energy cannot be created, cannot be destroyed. Okay, can only transfer. So when you jump electron level, then wait, something wrong. Energy level change. Energy go where? Well, so the solution is that the energy is actually either absorbed or emitted as photons. Ding, 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 ding. So like not just proton, neutron, and electron, now also got photon lah, quark lah. Yeah, this is very exciting one. Do you all regret being in like programming? No, I'm just kidding. This is a much better paying job. So anyway, these photons, right? These photons will trigger your photoreceptor cells inside your eyes. So based on the number of photons absorbed by the photoreceptor proteins in your photoreceptor cells, they will fire accordingly, and then your brain will interpret these signals as color. Amazing. So then, human beings, because human beings are most familiar with other human beings. We can only claim to know about other things, but like, let's be honest, we can't really see the world the way a red panda sees the world, right? But we have 3 types of cone cells. So it's like 3 trichromat. So we are like we are kind of like trichromats, I think. So those are there's a very badly drawn graph by me showing the wavelength of the different colors. So the 3 types of cone cells that we have, right, they are sensitive to different wavelengths. Like generally the relative sensitivity looks like these lines. Just, yeah, you know, 大概the shape like that, right? So we tend to perceive light within the green parts of the spectrum as brighter than red or blue lights when they are like equal luminance power, which is also kind of interesting when you go to the optician, right? Then they're like, okay, my optician speak Chinese. Let me translate for a bit. He's like, okay, green one brighter or red one brighter? And you're like, swap. Red one brighter or green one brighter? And then you swap. Yeah, I never understood why. Then I'm like, oh, okay, must be something like this. So then, okay, continue talking about polymaths, right? In 1802, there was a polymath called Thomas Young, and he introduced this idea that we had 3 photoreceptors inside our eyes that were sensitive to red, blue, and green. So I have a bunch of fun facts about this whole chromat thing. We try chromat, right? But like nature, you look out your window, I look out my window, I see a bird. Birds and fish, they are tetrachromats, which means they have sensitivity to UV, the UV spectrum. So actually they have better eyes than us, if you wanna think of it that way, because they have UV sensitivity we don't have. Apparently, right, like millions of years ago, our ancestors actually got 4 photoreceptors. But like, you know, I don't know, evolution, we lost something and then we gained back for blue light or something like that. I never go and read, but yeah. I have more fun facts. There are some organisms with 5 distinct cone cells. So like I said, scientists won't know what they really see, but they deduce that if you have 5 distinct type of cone cells, that must mean that you can, you know, detect like this, you'll be sensitive to 5 distinct wavelengths. So animals like these are like, surprise, pigeons, or like flying rats, as some people call them. Butterflies also have, and these are called pentachromats. I don't know, I think most of a sizable portion of the audience are guys. Males are more likely to be colorblind than females. This is actually because the gene for pigments in green and red cones are on the X chromosome. So Zabo, we got two X chromosomes. So we got backup. So if like one of the X chromosome, the red or green, like Salah, like not working properly, right? At least you still got backup. But for guys, you have one X and then one Y. So if your X is wrong, then, sorry lah, cannot see your green. So that's why the probability that you, so it's not to say that women can't be colorblind, it's just the probability that you have red-green color blindness is kind of statistically higher in men than women. Okay, last fun fact about cones. The mantis shrimp, like deep sea underwater creature, got 12 to 16 types of photoreceptor cells, which means that they can perceive wavelengths of light, right, from deep ultraviolet to infrared. So the long story short is that mantis shrimp eyes most tokong. Moving on. So just now Li Hao mentioned the term color space. But what specifically is a color space? Color space, right? It's let's call it a specific organization of colors. So it's actually became very relevant when people had to reproduce colors like consistently. So as you can see, the year that I printed there is like about 1853. It's about industrial age already. So there's like, again, another, this time is a German polymath. Name is Hermann Grassmann. I cannot pronounce this, so his name is probably wrong. I'm sorry. Please do not like flip in your grave. I apologize for pronouncing your name wrongly, Mr. Grassmann. But he developed this idea of a vector space because he was a mathematician first. So he invented the linear algebra and applied it to geometry. And he needed the idea of a vector space to have been solidified before he could propose his second color theory. And it's called Grassmann's laws. I think it's still being taught today. Is that the perception of the mixtures of colored lights composed of the different like the hue and spectral distributions, right? They can be algebraically related to one another on this 3D linear, this 3D vector space. So you have to create the vector space first and then say, okay, the color fits inside this vector space. And so essentially color space is like an algebraic representation of colored light. So I guess if you're mathematically inclined, you say, oh yes, I understand consistent numbers. Good for you. So I have to move on to another commonly seen phrase called gamut. I think if you fiddle around with your monitor, you'll see this sometimes on the packaging, like, oh yeah, like millions of colors, whatever. This is more terms and definitions. So if you're already asleep, I'm sorry, but I still got a lot more. Color gamut is actually very important for color reproduction. Why? Because it contains a complete subset of all the colors that can be represented accurately. Like again, this is for reproduction, for industrial purposes. So it's a subset of colors that can be represented accurately within this the color space that we're talking about just now. So actually gamut, right, it is borrowed from somewhere else one. Gamut comes from music. The gamut is a musical term for full range of pitches in a musical system. It's actually like mid 1800s, then people were doing color like, hey, I need a word. I borrow it from the musicians because why invent something new? So gamut. So if you're using a Mac, right? Okay, let's see if this can see. Mac quite fun. If you use Windows, I'm sorry. So it will generate this like really nice gamut visualization. I'm not on an external monitor. I think so you can see like different color spaces. So this is a color space, and it's more fun in 3D lah. I mean, you can see the flat diagram that kind of look like a U online. You go and search for it, but I always think the 3D one more accurate. Anyway, yeah, color sync utility, everybody. So during the Industrial Revolution, right, people wanted to reproduce colors for like mass production purposes. So you had to be able to like define it and then tell your producer or manufacturer, I want my X product to be in this specific color. You cannot just say, I like a reddish purple, more red, less purple, but not so little purple that you can't tell. I cannot. So you had to be more quantifiable. And so a lot of people went to research this, research mathematical descriptions of color, because if you want to quantify something, numbers is the best way to quantify, right? So the one outcomes of this intensive research is Theory of Pigments by Erwin Schrödinger. Schrödinger, if you have heard of Schrödinger, only because of the cat, I can tell you it's the same Schrödinger. Because why? Last time when people don't specialize, they do everything. So when he's thinking about quantum cats and everything, he was also thinking about colors. So amazing. Why nowadays we specialize so much? Like so tight. Anyway, he kind of proposed this theory, and his theory was that what the question he was trying to answer, right, is like, what is the maximal lightness, right? Lightness as in, okay, I'm not going to explain the word lightness, but what is the maximal lightness? What maximal lightness can a point of perfect spectral saturation, which means it's like the most colorfulness. What is this point where it can be realized with pigments, and what properties of these pigments, which is like their reflectance properties. So this is like, he's more thinking along the lines of solid like physics, not really light, but like solid physical colors, right? Like what's the reflectance function, like how much reflectance does this material need to recreate this color? And so reflectance is the measure of the effectiveness of a material surface to reflect radiance. So like it affects the saturation of the color you can see. So the most saturated colors can be created given a total reflectivity generated by the surfaces either having zero or full reflectance at any wavelength. This is actually inside the theory itself. So if you're interested, you can go and read it again. Translated into English. So if you don't understand German, also can read. But for now, right, like today, 2020, we still are unable to have a device that can reproduce the entire visible color space. So sometimes like the designers, everybody has a different color sensitivity. Some of the designers I know, they're very, very sensitive to color, and the color is always wrong to them. And then a lot of the developers are red law, like it's just like where's the difference? And then but to the designer, right, they actually can tell the difference. Like I said, because everybody's sensitivity to color is slightly different. So neither of you are wrong. It's just that you're perceiving different things. You know what I mean? Okay, moving on. This one I read 抄带过. So chromaticity is actually just measuring color in a quantitative manner. So the scale, right? The scale is called chromaticity. Right? Running out of time, moving on. So light is either emitted or reflected. So emitted would be more of like your digital displays. Then reflected is like a material. Like I don't know if you wear a traffic cone vest, then like wow, 很亮. But it's not actually emitting light, it's reflecting light. So this brings us to the two, I would say the broad color models, which are you can either be subtractive or you can be additive. So these are like just broadly speaking. So a color model, again, it is an abstract mathematical model of describing colors. So basically they're like generally we'll use like tuples of numbers to describe them, usually like 3 or 4 values for each of the color components. Actually, there are 5 major color models. I will not talk about all of them in depth, but like if you have any questions, can ask. So there are ICE later I will talk. RGB will be covered. YUV not covered. HSL and HSV is like slightly covered, and then CMYK also slightly covered. So let's start with. Oh, can I segue? Like, hello, host, got time or not? I promise this is like 2-minute segue. Okay, I just assume silence means consent. So what is this? What is this? Does this look like television? Television color bars. Television color bars are also very interesting. Actually, it was relevant because YUV was invented by these television engineers when they needed to convert from black and white TV to color TV. So they invented this color space that is like very specific for color transmission. Again, this is a segue lah. So 草草带过, right? If anyone had any question, can ask me later. It's cause like no time. But I just wanted to put this out there. Do you know why those of us here locally we see this one instead of that one? Go back. Because this one is for NTSC, and this one is for PAL. And PAL is not only technically superior to NTSC, only the American continent uses NTSC. Because for the rest of the world, the other continents, they were like, this NTSC actually is not very reliable. It's okay. We will wait for PAL to come out before we push color televisions to our broad public. Then on the American continent, they were like, it's okay, NTSC, we can live with the unreliability. So they had to like do some calibration. They do a lot more calibration. But the NTSC pattern is this one. And then those of us here, like of course I go and steal the Malaysia one. This is the TV3. Then like if you now last time don't have 24-hour TV one. Like after 10 PM, then no more already. Then you see this and then like that two right is like I check. I think it's 1 kilohertz. A lot of useless boliao facts from this talk. Anyway, segue over, moving back. Let's talk about CMYK. CMYK is used for printing and film. That's why like 草草带过就好. So they use the subtractive primary colors of cyan, magenta, and yellow. And then the K just stands for black. So magenta on the X, cyan on the Y, and yellow on the Z. And if you mix it, I think the people who developed this, they were a printing company, and they realized that this specific combination, and they also came up with this technique called process color, right? This produced the brightest colors. And if you are a print shop, you would want you want to be able to have the widest range of colors from the brightest to the least least saturated, right? So CMYK is subtractive because surfaces appear, you must understand, right? Like when we see something that has a color, right? It actually means that it doesn't absorb that color. So why we say subtractive? Subtractive is because surfaces look like they are a certain color because the wavelengths of light that they absorb and reflect. So when we see a leaf and it's green color, it's because it absorbs everything except green. It reflects green, so you see green. So black items, right? What they do is they absorb everything. So black, if you want to think about it another way, black is actually the absence of color. I got no random facts, but I have a random fact about CMYK. So if you're doing CMYK, right, the 100% black ink for CMYK, right, is not the darkest black possible. There's actually a dark, deeper black, and I don't know why, but it's called Photoshop black. And it absorbs more light than the 100% black. But it needs so much ink, right, that if you print on your paper quality not very good, right, your paper is just gonna like rip. So they use a lighter black. So it's like trade-off. For a lot of people, black is black. They don't think don't think so hard. So that's for subtractive, that's for print. But we live in a world with a lot of screens, right? Like I watched this comedian called Ronnie Cheong, and he said that our life's goal as modern human beings is how many screens can we fit between our face and the wall. I thought that was quite true. But so RGB, all light emitting displays use the additive color model. So RGB is basically if you're emitting light, you emit them as RGB. You won't use CMYK. It doesn't work that way. So RGB, right, is based on the theory of human color perception. So the digital displays that we have today, they are mostly pixel based. I think some of you who are like my generation or a bit older, you can remember like CRT monitors. Those are not pixel displays. Those use different. Those are like cathode ray. Again, no time, but if you're interested, can ask me. So when we talk about pixel density, right, every image you see on the screen is comprised of millions of colored pixels. Together, they make up this final image. But a single pixel, right, is actually three of these pixels combined together to form the final color. But because they are so close, we our eyes interpret them as like a single color. But like you zoom, and then you zoom some more, you can actually see the three component parts. And there are a lot of different pixel geometries for subpixel rendering. But LCD, they usually use like parallel, so like 3 stripes. But there are other patterns actually also. It's quite interesting. Again, can ask me like offline lah, no time, moving on. Okay, so this is the CSS part of this talk because it was a backup for CSS, so have to put in some CSS. So CSS was done in CSS since the first step, 1996 出来 you already can do color, right? So the initial application of color for there are 2 properties. You can use color for the text of an element, or you can use background color for the background element. Amazing. So at the time, color, they give you options. You can either use a keyword or you can use the numerical RGB specification. Hex codes actually are RGB. It's just that RGB they convert the RGB values to hex codes, but the value actually is the same one. Let me explain. This is a hex code. But like the constituent parts, if you are not colorblind, I hope you can see that like there is a red value, a green value, and a blue value. So hex just means base 16, right? And so you use all the digits 0 and 9, use finish. Then how? Borrow from alphabet. So A to F also add in. Then oh look, 16, amazing. And then hexadecimal actually is very popular in computer system because they are considered a human-friendly representation of binary code values. Apparently 4 binary digits is called a nibble. Don't know why. But you can spell it. You can also spell nibble NYBBL because it's spelled with a Y. But so each hexadecimal digit is in theory a nibble or half a byte. So instead of saying 1111111, I actually don't know how many ones I said. You can just say FF. So you can see how this works. Like this is the native color picker lah. So as you change the colors, right, you can see the proportion of each color, how they interact with each other. So like when I'm here in this like really bright green, right, the red and the blue is like almost not participating. Like they're just like, you know, not like green can play by itself. You move to yellow, right? Then it's like red and green, they have to work together to form yellow. And then the blue is like, nah, don't want to play with y'all. So then you see yellow and so on and so forth. Actually, this demo, this is actually quite fun because I use the native color input, right? Everybody's operating system color picker different one. So now this one, you only see the Mac one a bit boring. You can try Android. The Android one also quite interesting. Moving on. So this gentleman, I don't know how many of you know what is masonry. Maybe if you didn't work in an agency like me, you haven't heard this term, but if you work in an agency between, I don't know, 2009 to 2015, you 100% confirm your designer tell you, hey, I want a masonry layout. Masonry layout, right, basically is just the one where no matter what shape your rectangle is, it will like sort of stack up very nicely, no gaps. Must use JavaScript. This gentleman is the creator of the masonry library, yo. Know your guys. He's actually an amazing designer and developer. What I didn't know about him until 2018, when I saw this talk, is that he's actually colorblind. And he developed this really, really intuitive way to interpret hex codes. I'm not gonna spoil the conclusion, but .css talks are all 18 minutes only. So 18 minutes, it's not a waste of your time, okay? 18 minutes and you will never look at hex codes the same ever again. Highly recommend. Then, okay, because CSS transparent is a color. I remember when I first told people who were learning web development that transparent is a color, they just look at me and like, huh? This is why CSS doesn't make sense. No, it makes perfect sense. But yeah, okay, transparent is a value. And transparent is actually the initial value of background color. Like if you open blank page, don't set anything on background color, initial value is transparent. When it first started, again, from CSS 1 already got transparent because background color is the initial value. So as they modified CSS, right, by the time it came to CSS 2, they're like, oh yeah, okay, let's let people use transparent inside border color. Okay, can. By CSS 3, they're like, yeah, can. Anything that can take a color value also can use transparent. So it will just compute to RGB. So all the color functions, I think Lee mentioned this, it was like not sure what is the computer value. It will resolve to RGB. And this is because CSS uses the sRGB color space. I'll elaborate on that a little bit more right now. Yes. Clearly, I don't know what slides are coming. So sRGB is the color space that was actually created by HP and Microsoft. For monitors, printers, 重点 sorry, I'm using Chinese. The emphasis here is the web. So there's an original document if you're interested. But colors in CSS was first specified in RGB. RGB is not the best color space. Okay, let's be honest here. But even though there were better systems at the time, space, which is called CIEXYZ. And the problem with it is that when you use the transformation from CIEXYZ to RGB is slightly more computationally expensive. So back then, way back then, they were like, yeah, memory is not that like widely available as it was now. So they're like, RGB is good enough. Never mind, let's just go with it. Okay, this is to explain the next slide. But there's this thing called a color naming system. There was a potential proposal for CSS named colors, which came much later. CSS named colors came in CSS 3. That's about, I think, 2003. And so they were like, oh yeah, okay, if we want to have like name colors, we need to have a list of colors that come from somewhere. So Chris Lilly, who I mentioned earlier, his proposal was like, let's use this thing called this color naming system. It was created by a bunch of I think they are scientists in 82, and they created it in a very logical manner. Because there's this American system called ISCCNBS. It sounds a lot like KNNB, never mind. It was created by the Inter-Society Color Council. Yeah, this is an American standards board. But they have a very logical way for defining different hues of colors. So you have 12. The ISCC system had 12 basic color terms, and then they had modifiers. So this particular color naming system is based off that. They use 10 color names. So the color names listed here. So these base color names, right, you can combine or you prefix them with modifiers like to determine the lightness, to determine the saturation. And so with these combinations, right, you can go up to 620 chromatic names, which is like more than enough for describing. And it's not meant for computation, it's just meant for description, which is kind of a very logical way of describing colors. Because if you say something like, I mean, you know that light pink is it should be lighter than, I don't know, dark pink. If you look at the today's CSS name colors, you'll realize that there are a lot of funny things going on. This is CNS expressed in Bacchus-Noah form. So Bacchus-Noah is the form for all the CSS properties. That's how they are defined also. So like a name color can either be a gray color or chromatic color, where a gray color is this, a chromatic color that, blah, 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 blah. So these are all the different modifiers. So you can see like, okay, whitish, pale, brilliant, vivid. So it's like, okay, this is a very logical spectrum. And for shade, it's like, oh, blackish, dim, deep, vivid. So it's logical, like, you think about it. But no, CSS did not go with this. CSS went with the X11 colors. So that's why you got a lot of funny things like blanche almond, papaya wheat, lemon chiffon, cornflower blue is also a thing. This was the reason why they didn't want to use CNS at the time was because memory was was still expensive. Even like when they were proposing this, I think CSS2, can't remember what year already. That was the era of like Palm Pilots. Oh, host, I already passed 7 o'clock. I'm sorry. The things like Palm Pilots, right? The memory on these devices like can't really take a huge color list. X11 colors already existed on a lot of the systems, and X11 was widely implemented. Mosaic, Netscape Navigator, the earliest browsers, right? They both ran in X Windows system, so they already had like it was quite trivial to kind of convert your browser to recognize these X11 colors. Also, the original spec, right, they never provide the transformation to convert CNS to RGB. So in the end, they're like, so hard, and then X11. So he lost it. And so in the end, we use X11 colors. That's why the CSS name colors are so amazing. But somewhere along the lines, right, like RGB not enough. You wanted a color wheel representation of colors as well. So Li Hao already mentioned this HSL, right? So back then, color wheels not a new thing. Okay, like Isaac Newton's optics, he already created like the very early color wheel. So that was like 17 something, right? One of my favorite guys, Johann Wolfgang von Goethe, 1810. So the very rightmost color wheel, that's his. There's this quote again. This quote is in one of his theories. It's like, he said, when an eye sees a color, it is immediately excited, and it is its nature spontaneously and out of necessity at once to produce another. So he was very, I would say he's a compliment to Newton, because Newton was very analytic with color, right? He's like mathematical, rational, whatever. He's more interested in human color perception. So his experiments were more about the complexities of human color perception. Because Newton was looking at a mathematical model, Goethe was focused on exploring how color is perceived, right? So which brings us to, Munsell. Munsell is full name Professor Albert H. Munsell. And why is he significant? Because he's the first person that came up with a color space that was able to evenly distribute hue, value, and chroma into like evenly spaced out. Like before him, you couldn't uniformly all three axes. There was no universally even perception. You like bunched up in a certain section. He was the first one who developed this system. He called the Munsell color system. That was able to illustrate colors systematically in this 3-dimensional space. So that was his like early color sphere, which is great. And the C lab is CIE lab. CIE is a French organization. So even though it says International Commission on Illumination, it's not that people spell the acronym wrongly. Excuse me. In French, I cannot read French, but I think it's like Commission International d'Éclairage. So that's where the CIE comes from. International Commission on Illumination came up with CLAB, the LAB color space. And LAB stands for lightness, red, green, blue, yellow. Again, the acronym is not wrong, huh? It's just that they arbitrarily named red, green the A-axis and the blue, yellow the B-axis because naming things is hard, as you all know. So the CLAB gamut is much better than RGB and CMYK because it includes both of them. CMYK and RGB, you put the color spaces together, right? They're like small. They're small. CLAB just encompasses both of them, and it's a color space that is very human because it was meant to approximate human vision, right? The problem with it is that it needs more data per pixel to be as precise as RGB and CMYK. So when the hue wheel, so when this is the explanation of why HSL made it instead of the much better CLAB. Because when CSS needed a color wheel, they're like, yeah, this is the best one, but we end up in HSL. Why? Because again, it's easier to convert HSL to RGB. So, you know, life. Do you sense a pattern going here? But okay, to be fair, there were hardware limitations for computations as well. So it's like kind of a compromise. Like we can have a more intuitive color system. It's not great, but it's not bad, right? The problem is that HSL, fast forward to I think a couple of years ago, this is the entire reason why Li Hao could talk so much about SAS functions, because you needed a way to deal with these design systems whereby you have a base color and you want to generate, like programmatically generate related colors. HSL is not good enough, okay? This is basically how you interpret. Li Hao already described it, so this is like a very chui drawing of how you do it. 0 degree my red law, then like, you know, 180 degree blue, like that's how the hue looks like. Then it's a cylinder, like it's a toilet paper roll, okay? That's H, S, and L. So what's interesting here is that I swear I'm almost ending. 2 more CSS color modules have come up since CSS3, which is the one we are using all the time now. CSS4. CSS4 introduces HWB, lab colors, and LCH, which means Chris Lilly actually managed to get his wish 20 years later. So lab colors are way better, like I said, because today's hardware can do it. They can support the manipulation and computation of this much bigger color gamut. So CSS4 introduces more color spaces, or there's also a random gray function, because, you know, why not? I will not go into the actual syntax, but if you want to know, you can either read the spec or you can also ask me, never mind. This is how the again, badly drawn visualization, but color spaces are 3D ma. So that's the A and B axis for lab. LCH, right? C is chroma. So basically, how far away, like the further away, the more chromatic, the more saturated it is. But so LCH uses looks like something a bit more familiar to everybody from HSL. It's a 360 degree, then your modulo back for the hue. So that's the color spaces that we potentially have when CSS4 comes up. All of these actually, you can write your own color conversion functions if you don't really want to use SAS, right? You can use cup and custom properties to do that yourself. Color 5 is nice because just nicely I'll talk about all the different color mixing functions that SAS gives you. Under the hood, right? The pre-compiler has to do the conversion and computation. But with color module 5, right, there's 3 additional color manipulation functions. So yeah, they don't see. You know why CSS takes this long, no? Because CSS people have think about I cannot clash existing, like they will try not to clash with existing username. So instead I adjust color, they use what? Color adjust. I think actually you put color in front is also better, better naming convention. So there is color mix. Oh my god. Hello, typo, huh? I think it's a typo on my part. So I can't remember whether it's mixed color or color mix. But you can. So you have 2 colors, then the percentage is how much of the first color you want. For color contrast is good, because for accessibility purposes, right, you feed it. So the first color is your base color, and then everything after the first parameter is a list of colors. And your browser will tell you which one has the best contrast ratio, which is important for accessibility purposes. Anything less than, I think for the more stringent standard, anything less than 3 point something, not good enough. So I choose very obviously, like ghost white is white and then purple is quite dark. So of course ghost white would win, ratio 8.9. The algorithm will calculate that and it will return you. So this function will return you ghost white because ghost white higher contrast. And the last one is color adjust. So there's a bunch of color functions. I only use lightness here, but there are lots of different color functions you can fit in. So this is very, very, very similar to the sass function that you have talked about. So put in one color, manipulate it. CSS will do it for you in CSS color module level 5. So this is the end, because everybody need to go and see boyfriend, girlfriend, husband, wife, whatever, if you don't live together. So links, that's it. Okay, thanks, bye. Oh my god, it's so dark in my room. Let me go and tighten.
Wow, your room is dark. We just successfully
Will be no time. Sorry, I overrun now. Apologies to RK audience. Sorry.
Run this over sunset. So yeah, we do have some discussions / questions. Feel free to comment on it. I'll just read them all out together. So the first one is, if humans are more sensitive to green light, why isn't green light being used as stop indicator for traffic / emergency lights, but red instead? And then the other,
it's cultural. I think it's cultural.
Probably, or psychological. Right, and then the other one is, can you use font, the HTML font tag, font, and then attribute color equals to whatever the color is, and then
it still works. It's like even though it's not. The amazing thing about HTML, CSS, even JavaScript, right? Your old stuff mostly will still work one. Like they'll deprecate it. They'll tell you please don't use it, but they won't stop you from using it. That's why if I put in a BG sound tag onto my website now, you cannot hear it in a modern browser. But if you open IE, you can hear my annoying music. BG sound, one of my top HTML tags. So yes, to the answer the question, yes, you can still do it. Don't do it, but you can still do it.
Right. And then we have another one coming from Li Hao. So can we use CSS color module level 5 now? What's the browser implementation status now?
It's very early. Like am I still sharing my screen? Actually can see
with the
okay, so that's I was actually responding to some other things. It's very, very early. So if you look at the spec now, right, is on the stage where you like it's really, they discuss on the spec itself, so they're still trying to figure out like, okay, which proposal should we go? So it's very, very, very early. But given the speed at which things are moving these days, right, I won't be surprised that this might come sooner than we expect, simply because the people who are working on it, if you look at the spec authors, it's never say name. Got. So it's Leah and Chris. And then it's also these two folks from Google. They are the people who run the CSS podcast. So like subscribe if you haven't. And they're pushing for this because Yuna is very big on system, like design systems before she joined Google, even before she joined Google. So I think she's spearheading this quite a lot. They are so a lot of these CSS specs, right? It really depends on if the champion is pushing it forward. For color, I think is being actively worked on, as opposed to some of the more, I would say, how do you translate 冷门, core storage specs. Maybe that one won't move so fast. I think this one will come a bit sooner, but there's still a lot to work on because it's so early, right? So they're still working on like, okay, what's the interpolation function we should use, blah, 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 blah. But give them time to work it out. I think maybe, I don't know, next year, the year after, who knows, might come out already.
Ooh, okay, interesting. Well, okay, there are some further discussions on SAS functions for now, because that's what we have now. Right, okay, so I think let's wrap this up. If you, for those of you who are still here, if you have any further questions, you know where to find us. You can find us on Twitter, or I'll also leave this live stream open for a little bit more so that people can chill around a little bit. So yeah, thank you for joining us for this week again, and sorry about being a bit over time. Next week, we'll have an interesting sharing. It consists of a few lightning talks, but we're talking about a soft topic about prioritizing tasks, technical projects, or even technical debt. So I hope you guys will join us again next week, and I'll see you next week. Yes. All right. So I think